Okay, let's have problem 63. The bent rod is supported by a ball and socket joint at O, a cable at B, and a slider bearing at D. Neglecting the mass of the rod, calculate number 1, the tension in the cable, number 2, the magnitude D sub Y, and number 3, the magnitude of the Z component of reaction at D, or D sub Z. So this is the given figure. First, this is a slider bearing, so there's no reaction component along this rod. So only perpendicular to the rod, and that is dz and dy. So there's no dx. So we will denote the tension in the cable as T. Then the vertical component or the z component of T is, because this is vertical, horizontal, and it makes 60 degrees. So this is T sine of 60 degrees. The y component of tension is, because this is T cosine 60, then this is another right triangle, therefore it is T cosine 60, the hypotenuse, then the y component is T cosine 60 times cosine of 40. So that's it. While the x component in the opposite direction is T cosine 60, which is this, then sine of 40. So that is T cosine 60 sine 40. Those are the component reaction of the tension. Then because this is a ball at socket joint, there are 3 reaction components there. So let's assume these are the directions of the reaction components. Then at D we have dz and dy only. So let's also assume that dz is upward and dy is leftward. So to compute for the reaction at dz, we can sum up moments about oy, so that all the forces here will not be involved in the moment equations. Only dz and 8,000 will be involved, and therefore by right thumb rule, this is the y-axis, so positive in this direction. So 8,000 is positive. 8,000 times 0.9 equals dz times 1.8. So summation moment about y equals 0. 8,000 times 0.9 equals dz times 1.8. So solving for dz, dz is 4,000 newtons. So that's the answer to number 3. Then having found dz, we can sum up moment about OX to solve for the tension. So if we sum up moment about OX, by right thumb rule, dz is positive. dy passes through the x-axis because this slider bearing and O are on the same plane, same horizontal plane. And the component of the tension which has moment about OX would be T sine 60 only. This is parallel and this component passes through OX. And all reaction components at O are not involved also. So by right thumb rule, summation moment about OX equals 0. Then we have dz, or 4,000 times 2.4. Then plus T sine 60 times 2.4, then equals 4,000 times 1.2 plus 8,000 times 2.4. So 4,000 times 2.4 plus T sine 60, dz is 4,000, take note, times 2.4 plus T sine 60 times 2.4 equals 4,000 times 1.2 plus 8,000 times 2.4. So we can now solve for the tension. The tension is 6,928 to 4 significant figures. Then finally, for the magnitude dy, we can sum up moment about OZ equals 0. Then by right thumb rule, your right thumb should be here. Positive moment should be in that direction. So t cosine 60 sine 40 would be positive times 2.4. T cosine 60 cosine 40 is not involved. T sine 60 is not involved. T cosine 60 cosine 40 passes through OZ. T sine 60 is parallel to the Z axis, so not involved. All these vertical forces are not involved. So it's only T cosine 60 sine 40 times 2.4, then equals dy times 1.8. So that would be the equation. So T, which is 6928, cosine 60 sine 40, the moment arm is 2.4, then equals dy times, this is 1.8, distance of line of action of dy from OZ is 1.8. So solving for dy is 2969 Newton. So you may have a different equation, but these are the answers. So that's it for this problem. I hope that you were able to follow the solution. So let's proceed to problem 64, example 64. A 1,500 kilonewton weight is supported by three cables AB, AC, and AD. Find the tension in cable AB, tension in cable AC, and the tension in cable AD. So the forces are concurrent but not non-coplanar. So it is best to describe each tension force into vector form so that we can determine the x, y, and z components of each tension. So let's call tension in AB as TAB, AC TAC, and AD TAD. And of course, the weight is 1,500 downward, which is in vector form negative 1,500 K. So TAB in vector form is magnitude of TAB times it is directed forward along X 2, then upward along Z 2.5. So no movement along Y. So that's why it is 2I, then 0J, no movement along Y, then positive upward 2.5 along Z. So 2.5K divided by distance square root of 2 square plus 0 square plus 2.5 square. Simplifying, that's TAB times 2I plus 0J plus 2.5K over square root of 10.25. So meaning the x component of tension AB is 2 over square root of 10.25 of TAB. The y component is 0. The z component is 2.5 tension AB over square root of 10.25. So while tension AC is directed backward, so negative 3I, negative 1.2 J, then positive 2.5K. So tension, magnitude of tension AC, negative 3I minus 1.2 J plus 2.5K over square root of 3 square plus 1.2 square plus 2.5 square. Simplifying, that's tension AC times negative 3I minus 1.2 J plus 2.5K over square root of 16.69. And finally, for tension AD, it is up along Z 2.5, then along X 0, but along Y positive 1.5. So tension AD in vector form is magnitude of tension AD, quantity 0I plus 1.5J plus 2.5K over square root of 0 square plus 1.5 square plus 2.5 square. Simplifying, it is magnitude of tension AD, quantity 0I plus 1.5J plus 2.5K over square root of 8.5. We then set up the equilibrium equation, summation forces x equals 0. So take note, the 1,500 has no x component. So we have negative 3 over, we have, sorry, 2 over square root of 10.25 TAB, then minus 3 over square root of 16.69 TAC, then plus 0 TAD over square root of 8.5 equals 0. Equation 1. Summation forces y equals 0. And we have 0 TAB over square root of 10.25, then minus 1.2 TAC over square root of 16.69, then plus 1.5 over square root of 8.5 tension AD equals 0. So the 1,500 kilonewton weight has no Y component also, only the Z component. So finally, summation forces along Z equals 0. So we have 2.5 TAB over square root of 10.25 plus 2.5 over square root of 16.69 tension AC plus 2.5 tension AD over square root of 8.5 equals 1,500. So that's equation 3. Solving these three equations simultaneously gives us the following values. So tension AB is 873.2 kilonewtons, tension AC is 742.8 kilonewtons, and tension AD is 424.1 kilonewtons. So that's the solution to this problem, and again, I hope that you were able to follow the solutions. For problem 65, the bent bar of negligible weight is supported by a ball and socket joint at O, a cable connected between A and E, and a slider bearing at D. The bar is acted on by a wrench consisting of the force P and a couple C, both parallel to the z-axis. Determine number 1, the x component of the bearing reaction at D, the z component of the bearing reaction at D, and the magnitude of the force in the cable. So here we go. This is the figure. So there's no y component of reaction at D because this is a slider bearing. So this rod will just slide along the y-axis or along dy. So the couple is directed downward. So in vector form, it is negative 1,800 Newton meter K. So we denote the tension in the cable as T. Then the components, we will write this in vector form so that we can easily determine the components. Then we put the reactions. So these are the components of tension. Tx should be in the opposite direction, in the negative direction. Ty in the positive direction because the tension is directed from A to E. And Tg is upward because from A to E, that's upward. Then bearing reactions at O, OX, OY, and OZ. And the bearing reaction at D, we only have DZ and dx. So let's assume that dx is forward and dz is upward. So first we sum up moment about OX so that we can compute dz. So if we sum up moment about OX, all forces on OX will not be involved in the moment equation. So what would be involved would be dz and this 2000 Newton force. The couple has no x component because it is negative 1800 K or along Z only. So summation moment, so this is the couple in vector form. This is the tension in vector form T times negative 1.2 I backward. Then along Y is positive 0.6, 0.6, and 0.9. So that would be 1.2 plus 0.9, 2.1 J. Then along Z is upward 1.2 K divided by distance square root of 1.2 square plus 2.1 square plus 1.2 square. So simplifying, the x component of tension is negative 40 over 9. The y component is 70 over 9 and the z component is 40 over 9. So it is indicated in the figure why the x component is negative. It is backward. Y and z are both positive. So summation of moment about OX equals 0 by right thumb rule. So your right thumb should be here. So the curling of your forefinger would be in that sense. So dz is positive, 2000 is negative. So dz times 2.1 equals 2000 times 0.6. So that would be the equation. dz times 2.1 equals 2000 times 0.6. So we can now solve for dz. It is 500 871.4 newtons, the answer to the second problem. Then knowing dz, we can sum up moment about oz, but there are two equations, two unknowns involved, dx and the component of tension, which we do not know yet. So anyway, summation moment about OY, we have also two unknowns. So right thumb towards the positive y-axis, so the positive moment should be in that sense. So dx is positive, dx is 0.6 meter above the floor, above O, A, and this corner here, and this point here. So dx is positive, dx times 0.6. This component of tension passes through y, so not involved. Parallel to y-axis, not involved. So Tz is negative, while 2000 is positive. So dx times 0.6 plus 2000 times 1.2 equals Tz, where Tz is 40 over 9 times 1.2 equals 0. So the couple is not involved because it is negative 1800 K or along Z only. So again, dx times 0.6 plus 2000 times 1.2 then equals Tz, which is 40 over 9, moment arm 1.2 plus dz, which is 571.4, moment arm is also 1.2. So simplifying, we have 0.6 dx minus 8 over 15t equals negative 1714.32. So we will call that equation 1. Next is summation moment about OZ equals 0, so that all these component reactions that are not involved. So your right thumb towards the positive z-axis, so the curling of your fingers would be this. So this is the positive sense of moment. So therefore, Ty is positive, Tx is not involved, it passes through OZ. Tz is parallel, so not only Ty is involved for the component of tension, and that is positive, Ty, which is 70 over 9 times 1.2. Then this is negative 1800, this is involved. Then equals dx times 2.1. So the equation is Ty, or 70 over 9 times 1.2, then minus 1800, because this is negative 1800K, then equals dx times 1.2 plus 0.9, so 2.1. So equals dx times 2.1. Simplifying, 2.1 dx minus 14 over 15t equals negative 1800. So solving equations 1 and 2 simultaneously gives us the following results. dx is 143 newtons and the tension is 4,500 newtons. So that's it. That's the solution to this problem. So for problem 66, the 6-meter pole ABC is acted upon by a 455 Newton force as shown. The pole is held by a ball and socket joint at A and by two cables BD and BE. For A equals 3 meters, determine the tension in each cable and the reaction at A. So this is the figure. We will denote tension in BD as TBD and tension in BE as TBE. Then we will define all these tensions in vector form as well as this force and transmit the component reactions at D and at E. For TBD at D, for TBE at E. You can actually transmit it at B, but because there are so many component reactions at B, then it might be difficult to visualize the components. Then for 455, we transmit the components of 455 at F. So because this is a ball and socket joint at A, let's assume that the component reactions are all positive or towards the positive directions. Then this is 3 meters. So tension BD is magnitude of tension BD. It is directed 1.5 I along X. Along Y is negative 3, so negative 3J. Then along Z is also negative 3K divided by distance, square root of 1.5 square plus 3 square plus 3 square. So simplifying, it is TBD times 1.5 I minus 3J minus 3K over square root of 20.25. Then tension BE is in vector form is magnitude of tension BE times 1.5 I minus 3J then plus 3K. So since they have the same components except for the Z component, the distance is the same. So TBE times 1.5 minus 3J plus 3K over square root of 20.25. For the 455 Newton force, FCF, 455 times negative 3I, negative 6J going down, then positive 2K. So down, leftward 3, so that's why negative 3I. Down along Y is negative 6J, 6. Then forward along Z, positive 2K. Over distance, square root of 3 square plus 6 square plus 2 square. So simplifying, it is negative quantity negative 195I, negative 390J, 130K Newton. So this is the X component. Towards the negative X direction, the Y component is going down, and the Z component is forward along Z. So these are the components of tension BD, components of tension BE. So let's assume these are these are the directions, and the components of the 455 Newton force, 195 leftward, then downward 390, then forward 130. So first we sum up moment about uh, a AX equals 0, so that the involved components would be TBDY and TBEY, and this 390 newtons. So 130 is passing through X, same floor. 195 is parallel. So this is parallel to X. TBEZ passes through the X-axis, AX. Same is true with tension BDZ. And this is parallel, so only TBDY, TBEY, and 390 are involved in the moment equations. So by right thumb rule, we have TBEY, and TBEY is 3 over square root of 20.25, because this is already downward. Don't mind the negative sign there. That's downward. Times 3 plus 390 times 2, then equals TBDY. TBDY is 3 over square root of 20.25 of TBD. Then the moment arm or distance of TBDY from the AX axis is 3. So that's why times 3 there. Simplifying, we have 2 tension BD minus 2 tension BE equals 780. Call that equation 1. Then summation moment about AZ equals 0. Then not AY, because if AY, there will be so many component of reactions in tension that are involved. Here 2, here 2, then 2 also involved for the component reactions of the force or components of the force. So unless we sum up moment about AZ, then TBEX passes through AZ parallel, so only TBEY and TBDY are involved, passes through AZ and parallel to AZ. And for the components of force, only 390 is involved because this is parallel, and 195 passes through AZ axis. So by right thumb rule, positive moment is in that sense. So we have 390 times positive 390 times 3, then equals TBDY, which is 3 over square root of 20.25 times TBD times moment arm, which is 1.5, plus TBEY, which is also 3 times 3 over square root of 20.25 of TBE. Then the moment arm is also 1.5. So simplifying, we have TBD plus TBE equals 1170, equation 2. Solving these two equations simultaneously, we can now solve tension in BD equal to 780 newtons, tension in BE 390 newtons. So those are the tensions in the cables BD and BE, and the so that's it. And for the reaction at A, summation forces X equals 0. So AX plus TBDX plus TBEX equals 195. That would be the equation. So AX plus 780 times 1.5 over square root of 20.25. That's the X component of tension in BD. Then plus TBE 390 times 1.5. This is the X component. 390 times 1.5 over square root of 20.25 equals 195. Solving for AX, AX is negative 195 newtons. So it is negative, it is directed in the opposite X direction. Then summation forces Y equals 0. AY equals 390 plus TBDY plus TBEY. So AY equals 390 plus 780 times 3, 780 times 3, this is over square root of 20.25, that's the Y component of tension BD, plus 390 times 3 over square root of 20.25. Solving for AY is 1170 newtons. Then finally, summation forces along Z equals 0. So AZ plus 130 plus TBEZ, which is 390 times 3 over square root of 20.25 equals TBDZ, which is 780 times 3 over square root of 20.25. So AZ plus 130 plus 390 times 3 over square root of 20.25 equals 780 times 3, which is the Z component of TBD. So 780 times 3 over square root of 20.25. Solving for AZ, AZ is 130 newtons. So the reaction at A in vector form is quantity negative 195I plus 1170J plus 130K close newtons. So that's the reaction at A in vector form. So that's it for this problem. For problem 67, this is about determination of zero force members in a truss. So identify zero force members in the truss shown below. So remember, there are two cases, and case 1 is when there are only two members meeting at an unloaded joint, then automatic, those forces carry no force. And the second one is if there are three forces acting at a joint and the two are collinear, then the member that is unique carries no force. So we cannot find a joint where there are only unloaded joint where there are only two meeting members. At A, there are two members, but there is a reaction definitely at A because this roller or rocker, there is a vertical reaction there. So definitely this does not belong to case 1. As well as at I, we have vertical reaction. The horizontal reaction is 0 because the loads are vertical. So beginning with, we cannot find case 1, so we proceed to case 2. So we start at joint N. So if we look at joint N, there are three meeting members, two are collinear. Therefore, the unique member, which is Cn, carries no force. Obviously, summation forces y at n is equal 0, Cn is 0. Having found Cn is 0, you can proceed to joint C. So at joint C, there are four meeting members, but Cn is 0. If we remove Cn because it carries no force, joint C reduces to three members and two members are collinear, BC and CD. Therefore, the unique member Cl carries no force. So Cl is 0. Then we proceed to joint E. And this is case 2 again. Two are collinear, unloaded joint. Therefore, EL carries no force. So EL is 0. Then we proceed to this joint at I. Since this is 0 and these two are collinear, definitely they carry equal force. But because this is 0, this is also 0 if you sum up forces along X. Therefore, IJ is 0. If IJ is 0, if we proceed to joint J, then summation forces X, because these two are collinear, then automatic JK is also 0. Then we proceed to joint A. Since this is like case 2, two forces are collinear and AN is unique as a unique line of action. Therefore, if we sum up forces along X, AN is 0. Then back to joint N, because this is 0 and it is collinear with NM. So therefore, AN and NM are equal. They are collinear. And therefore, they carry the same force. And because AN is 0, so NM is also 0. So that's it. We cannot find another case for case 1 or case 2. So the zero force members are AN, MN, CN, CL, EL, IJ, and JK. So those are the zero force members for problem 67. For problem 68, identify zero force members in the truss shown below. So we cannot find case 1 here. Two meeting members. There are two meeting members here, but it is loaded at A. So there's no case 1. But case 2, there's so many. So beginning at F, the members AF and FI are collinear. This is unloaded, therefore force in BF is 0. If force in BF is 0, if we proceed to joint B, it's like removing BF because it's 0. So again, joint B reduces to three members. Two are collinear, AB and BC. Automatic BC is 0. If we proceed to joint G, then there are actually four members, but because we already found BC 0, so this reduces to three members only, and CG and GI are collinear. GJ is unique, therefore GJ is 0. Then we proceed to joint J. So at joint J, there are four meeting members, but GJ is 0. If we remove that, 2 are collinear again, IJ and JK. Therefore, force in HJ is 0. Then if we proceed to joint D, this is case 2. 2 are collinear CD and DE. Automatic DH is 0. Then if we proceed to joint H, there are actually 5 members, but we remove DH and or ignore DH and HJ, so it reduces to 3 members, CH, HK, and HE. Since CH and HK are collinear, automatic, HE is 0 or EH is 0. And no more, no more. So those are the zero force members. We have BF, BG, C, there's no C, GJ, GJ, and GJ, then HJ, DH, and EH. So there are 6 zero force members for this case. That's it for this problem. And this is the final problem for this series of problems. Identify zero force members in the trash shown below. So this is the given figure. And if we take a cursory look, we have case 1 here. So at joint A, there are 2 meeting members and A is unloaded. Automatic AB and AF would be 0. Summation versus X 0, so AB is 0. Summation versus Y 0. AF is 0. Then another joint that falls in case 1 is joint E. So automatic DE and EJ would be 0. Then we cannot find case 1 anymore, but we have case 2. So at joint C, BC and CD are collinear, automatic CH is 0. At joint L, KL and LM are collinear, summation versus Y, automatic CL is 0. And at joint N, MN and NO are collinear, automatic IN is 0. So that's it. And we cannot find zero force members anymore. Therefore, the zero force members are AB, AF, DE, EJ, CH, GL, and IN. So those are the zero force members.